Good morning. This is Mr. Burns, CPDLF science instructor, and it is Tuesday, January 2nd. I hope you all had a great Christmas and a happy New Year celebration and a great break. I know I enjoyed that break. I enjoyed sleeping in some and things like that, so I hope you did as well. And I hope you're ready to go again for another, you're almost at the end of the semester here. You've got a little bit left to go before the end of the quarter, but I hope you're ready to jump in again and make yourself successful again. Just to get everyone going, last time we took quiz 1. That was chemical reactions at 7.8 in your lesson, in your course, I mean. You did enthalpy of a reaction, 7.9. You did heat transfer, 7.10. You did calorimetry, 7.11. And using Gibbs free energy to predict spontaneous reactions, 7.12. You also did quiz 2, chemical change to entropy, and Gibbs free energy, 7.13. So I hope that actually all those 7s are 1s. Let me go through that again. Lesson 7, chemical reactions is 1.8. Enthalpy of reaction is 1.9. Heat transfer is 1.10. Calorimetry is 1.11. Using Gibbs free energy to predict spontaneous reactions is 1.12. Quiz 2, chemical changes to entropy and Gibbs free energy was 1.13. They're actually unit 7 in the course, but you're already working in the second half of the course here, so they actually switch back to 1s. Sorry about that. If anyone has any questions on any of those, please let me know. I am more than willing to give you a hand and help you work things out. Now, our reflection question for last week was define enthalpy. And that's a lot of what we did last week. Enthalpy has to do with energy, but it isn't just energy. It's a particular kind of energy. And we measure it. How do we measure that? Okay. Just remember, calorimeters are used to do this. Enthalpy can be part of a spontaneous or even a non-spontaneous reaction. In a non-spontaneous reaction, we add something, okay, that enthalpy measures, and with a spontaneous reaction, it just occurs. It's given off. So you need to say what that is. Also, what is entropy? Okay. Think about that. Entropy is disorder. Scientists have realized that everything proceeds from a type of from greater order to lesser order. Okay, and so that's what entropy is. Things do not just devolve sort of into having less order. And so that's part of what you need to know here as far as what's called Gibbs free energy in that last lesson. If there's any questions on any of that, please let me know. I want you to be successful. Okay, now for this week, the week of the January 2nd to the 5th, you're going to look at factors that affect reaction rates, solution concentration, that's 1.14. You have an experiment, the effect of solution concentration on reaction rate, that's 1.15. Factors that affect reaction rate, temperature catalysts, concentration of reactions, that's 1.16. You're going to take quiz 3, a chemical change to reaction rate, that's 1.17. And you're going to take the lesson called reaction equilibria and equilibrium constants, 1.18. Now I know there's a lot of big words in there and you might think some of that's confusing, but the more you work with it, the easier it gets. It's really not as hard as it sounds right there. But please let me know if you have a problem with any of that. I will be glad to help you. Your reflection question for this week is, how does the concentration of a solution affect the reaction rate in chemical reactions? I'll say that again. How does the concentration of a solution affect the reaction rate in chemical reactions? So be sure to answer that question and you will get credit for attending this launch. So I wish you a great week as you get back into work again. I know it's a little hard to get back into work after a break, but give it your best. You want to be successful, and I want you to be successful too. So if you need anything, let me know, but have a great week. Talk to you later. Bye.